Experiment 3. Measuring gravitational acceleration. The objective of this experiment is to investigate the functional relationship between height of fall and falling time. The second objective of this experiment is to determine the acceleration due to gravity by studying the motion of a free-falling body.
How are we supposed to do this experiment? Now I will explain about the procedure. First, we have to set up this apparatus until it becomes like this. Next, we have to measure the height from the bottom of the ball to the top of the tiny pad. We have to record the height in the data table. The next step is we have to raise the pen by hand and make sure to raise the pen after each single measurement. Then you have to place the ball in the release mechanism. Then we have to press the 0 button. After that, click the start button to begin the data recording. Then loosen the thumb screw to release the ball. And then repeat the same steps but with the different measurement. From the graph of height of fall as a function of falling time, we could calculate the gradient. The gradient that we get is 5. This is the minimum and also the maximum of gradient. And from the gradient that we calculate, we could calculate the gravitational force using the kinematic formula. The formula that we use is distance equals to initial velocity times time plus half times acceleration times t squared. Hence, the gravitational force that we get from this graph is 10 meters per second squared. The experimental value that we get is 10 meters per second squared, while the theoretical value is 9.81 meters per second squared. This explains that we have an experimental errors while doing the experiment. Hence, from that, we have to find the percentage error that involved in this experiment. Using the formula, we could get the percentage error is 1.9%.
Discussion. The purpose of this experiment was to measure and confirm the acceleration due to gravity by timing a free-falling ball, and to investigate the functional relationship between height of fall due to falling time. A source of error that may have been present during the experiment is a systematic error in the electrical signal between the circuit is when the ball is released to when it hits the plate. This experiment needs to be alert toward the acceleration digital counter. As an example, we need to make sure that the digital counter must be in 0 to get the accurate gravitational acceleration. Other than that, different position on the metal sphere change the value of time.
From the experiment, this is the graph that we can get from the data. From the graph, we could observe that height of fall are inversely proportional to time, which is t. Which means this graph represents the velocity of the object. Hence, we could conclude that the greater the height of fall, the slower the falling time is. This is the graph that we get for height of fall versus time squared. What we could observe from the graph is the height of fall is directly proportional to time squared, which graph height of fall versus time squared actually represents acceleration. And in this experiment, acceleration is equals to gravitational acceleration that we need to find. Hence, when the height of fall are directly proportional to time squared, it means that the objects are accelerating uniformly. The conclusion is the height from which an object is dropped and the time of fall does not affect its acceleration. By comparing the experimental result that we get, which is 10 meter per second squared, and the theoretical value, which is 9.81 meter per second squared, we're able to count the experimental error that we get, which is 1.9%. So we could conclude that the acceleration due to gravity is equals to 9.81 meter per second squared. So that is all for our video. Thank you so much for watching.